Hi students, in this video I'll be going through the 2021 O-Level Mathematics paper 1 question 20. Alright, so this is a question regarding LCM and HCF as well as perfect cubes. Okay, so let's read the question. Okay, so they say that for part A, written as a product of its prime factors, 12 equals to 2 square times 3. Okay, so we know that 12 is 4 times 3, and then what they do is that they prime factorize 4, so 4 becomes 2 square. Okay, so for part 1, they want us to write 144 as a product of its prime factors. Okay, so this one is something that all of you should be very well versed in, so not something very difficult to do. Okay, so we know that 144 is actually 12 times 12. So usually what I like to do is I like to break up the number into smaller numbers first, then prime factorize the small numbers and then combine together. Okay, so in this case, the question already told us that 12 is 2 square times 3. Okay, so we can put 2 square times 3 inside for both. Okay, then all we need to do is use the law of indices to combine. So those with the same base 2. Okay, so both have power 2, so add up the power will become 4. And then the 3 times 3 will give you 3 square. Okay, so part 1 is very easy to do. Okay, let's look at part 2. Okay, so part 2 is the one that I would like to discuss. Okay, the highest common factor HCF of two numbers is 12. So over here you have two numbers. Okay, the lowest common multiple of that same two numbers is now 144. Okay, both numbers are greater than 20. Okay, so whenever you read the question, you can go underline the keywords. Okay, so you don't have to keep rereading the question over and over again. Okay, so what they want us to do is find the two numbers. Okay, so over here our objective is that we have two numbers. Okay, so the first number, okay, we want to find it. Okay, and then we also want to find the second number. Okay, so what is the info that they give us to find these two numbers? Okay, they say that these two numbers, right, the HCF is actually 12, the highest common factor. Okay, so we know that 12 is 2 square times 3, right? Okay, 2 square times 3. So I will write it in the prime factorized form. Okay, then they say that the LCM is actually 144, which we know to be 2 to the power of 4 times 3 square, right? Okay, so the info given us to us is this. Okay, so before we find these two numbers, I would like to recap, right, how we can actually find the HCF and LCM if we are given the two numbers instead. Okay. Okay, so I'm going to give an example over here. Okay, so let's say we have the number 72. So 72 is if you prime factorize, you get 2 cubed times 3 square. And then over here, let's say I have another number 324. If you prime factorize, you get 2 square times 3 to the power of 4. Okay, so if I want to find the HCF, okay, can you recall how we can find the HCF of two numbers when we have already prime factorized it? Okay, so always remember HCF stands for highest common factor. Okay, a factor is a number that can be found inside both of these two numbers. Okay, a factor is a number that can be found inside of these two numbers. So if you can be found inside of these two numbers, you have got to be smaller than the two numbers, right? Okay, so HCF, okay, is the smaller number, okay, if compared to LCM. Okay, so for the smaller number, it's very easy. We just have to compare each of the individual prime factors, right? So over here, you see you have 2 cubed. Over here, you have 2 square. Okay, so we want to focus on the power. Okay, focus on the power. Okay, so for HCF, you will take the one with the smaller power. Okay, so in this case, for HCF, we will take the 2 square. Okay, so you do likewise for the 3 square and the 3 power 4. Okay, so it's quite obvious that 3 square is smaller, right? So we will take the small. It's 4 times 3 square 9, so you get 36. So the HCF on 72 and 324 will be 36. Okay, then for LCM, you will do the opposite. Okay, you will look at both compare the two prime factors, and you take the one with the bigger power. So now you see 2 cube and 2 square. 2 cube is the bigger power. Okay, why do you take the bigger? Because LCM stands for multiple. If you are a multiple of something, means you must be bigger than something, because a multiple means you take something times something else. Okay, so if you multiply to something, you become bigger. All right. Okay, so LCM, you will take the one with the bigger power. So same thing, you compare the 3 square and 3 4, then you will take the 3 power 4. Okay, so you will get 648 if you go and calculate out. Okay, so this is how you find the HCF and LCM when given the two numbers. Okay, so this question is a bit more complicated, because now you are given the HCF and LCM. Instead, you try to find the two numbers. Okay. Okay, so one of the method that I always use, you see, the prime factors here are 2 and 3, 2 and 3, right? So I'll write 2 times 3 for both. Okay, then all I need to do is I need to try to fill in the powers. Okay, I need to try to fill in the powers. Okay, so you see the fact that the HCF is 2 square, that means one of them must have a 2 square. That's why when you compare it, right, then you will take the 2 square, you will choose the smaller one and take the 2 square. Okay, so the fact that a 2 square appears for the HCF means one of the numbers must be 2 square. And likewise, the fact that the 2 power 4 appear in the LCM, right, that means one of them must be 2 power 4. Okay, so when you do the comparison, you see, okay, if I'm comparing the prime factor 2, okay, I want to find the HCF, I will take the top one, okay, 2 square, the smaller power. If I want to find the LCM, I will take the 2 4, which is the bigger power. Okay, so do likewise for the 3. Okay, but now the 3, you need to pay attention to this particular condition given here. So numbers must be bigger than 20. Okay, so over here you see 3 and 3 square, right? So one of them must have a 3. Okay, but what if I write like this? Okay, okay, technically there's nothing wrong here. If you try to find the HCF, LCM from these two, you will still get the same two answers. But now you see, if I take 2 square times 3, I only get 12 for here. It's not greater than 20. So this one doesn't work. Okay, so what should we do? We should switch it up instead. We'll write the 3 square here and the 3 at the bottom. Okay, because if we were to multiply now, okay, now they want us to find the two numbers, so you can't leave your answer and the prime factorize 4. Okay, you have 4 times 9, then you will have 36. So it's correct because it's bigger than 20. Okay, this one, 2 power 4 is 16. 16 times 3, you will get 48. So it's also bigger than 20. Okay, hence this will be the two answers there. All right. Okay, so this is sort of like reverse engineering the question now. Okay, usually they give us the numbers, we find the HCF and LCM, but sometimes they give us the HCF and LCM, then we go backwards and try to find the numbers. All right. Okay, let's look at part B of the question. Okay, so part B is regarding perfect squares, perfect cube. Okay, perfect cube over here. Okay, so they told us that written as a product of its prime factors, 784 is 2 power 4 times 7 squared. Okay, the number 784 divided by P over Q will become a perfect cube. Okay, where P and Q are prime numbers. Okay, find the value of P and Q. Okay, so over here they told us okay, let's write out in a statement what the question is telling us. Okay. They say if you take 784 divided by P over Q, right, the result will be a perfect cube. Okay, so if you recall, what is the definition of a perfect cube? Okay, basically, the easiest way to remember is a perfect cube is a number, right, that you can represent as the cube of an integer. Okay, that means perfect cube must be an integer and cube. It must be able to be represented in this way. So in other words, you agree with me, if integer cube means it's an integer, okay, the same integer multiplied by itself 3 times. Okay, integer times integer times integer, and all these three must be the same, okay, the same integer. Okay, these three things must be the same integer. Okay, basically what I'm going to do now is, okay, over here is a divide. We are more familiar with time, right? Times. Okay, so if I change to multiplication, I will need to flip this fraction. Okay, so Q over P. Okay, so I'll change it to this. Okay, then what I'm going to do is I'm going to replace this 784 with the prime factorized form, which they have already done for us. So I will write it as 2 power 4 times 7 squared times Q over P will become a perfect cube. Okay, so we already mentioned that perfect cube must be an integer, okay, times itself for 3 times. Okay, so what I'll do is I'll write the 3 brackets over here. Okay, then for the next part, what I'm going to do is I'm going to divide. Okay, over here we have 2 power 4, right? I'm going to split them up as evenly as possible within these 3 brackets. So this will not be difficult to do. It will be 2 times 2. Then over here we'll have 2 2s. Okay, because total there are 4, right? Okay, then I'll do likewise for the 7. I'll put times 7 times 7. Okay, there's only 2 7, so the third bracket does not have a 7 currently. Right, so if you think about this question, what we want is the same integer in the 3 brackets, right? Okay, you see the first 2 brackets already have the same integer, which is 2 times 7, 14, right? Okay, 2 times 7, 14. So now what our objective is to make this one the same. Okay, make this the same. Make this 2 times 7. Okay, so how can I make this 2 times 7? Okay, you see there are 2 2s over here. Okay, there are 2 2s over here in the third bracket, but I only want 1 2, right? So in order to get rid of it, I need to divide by 2. Alright, so I need to divide by 2. Okay, then the next thing will be, okay, I'm going to change the color marker again. Okay, you see there's a 7 7 here, right? 7 7, but here doesn't have a 7, so I will multiply by 7. Okay, so if you do a comparison to this one, okay, multiplying by 7, you multiply by 7. Okay, so this Q has got to be the 7 already. Right, so can you see it now? So the Q has got to be the 7. And then the same thing goes likewise for the P. Now you divide by 2, right? You see the divide over here, divide by P. So now the P has got to be the 2. Right, so this is how you identify what is Q and what is P. Right, so this is how you do the question. Okay, so it's very important to remember perfect cube means an integer cube. Okay, a number that can be represented as an integer cube. So that's why I divided into 3 brackets. Okay, if the question is asking about perfect square, okay, which they might ask, okay, then you just divide into 2 brackets, because a perfect square will be a number that can be represented as an integer square. Okay, so this is how you approach a question like this. Right, so I hope that this video is helpful for you in clarifying, okay, how to solve questions such as this. Right.